Hello there, and welcome back. In this video, we are going to be looking at volume, what volume is, how to calculate volume, and you will need the memory pieces for this one. These are item 33. There are 3 of these. They sort of look like Rubik's Cubes or some weird construction game. I've seen these. But this is dealing with volume. So go ahead and get these pieces together. I'm going to take mine away for just a minute because there are some things I want to tell you first. First thing I want to do is give my page a title, and I'm just going to call it Volume. Now, before I give you the info on volume, I want to remind you about 2 other types of measurement. One of them is a perimeter. So let me just sketch a picture for you, and you might want to do this too in your notes. Let's just draw a rectangle. And we know that rectangles have equal lengths, and then they have equal widths. They have 2 sets of parallel sides. So let's say that this is 15 meters. That means this one is also 15 meters. And that this one is 8 meters, which means that this one is also 8 meters. Now, to find a perimeter, let me just tell you the etymology of this word. Peri means around. Meter means measure. So perimeter is the measure around something, from corner to corner to corner to corner and back again. So the perimeter of this shape is 15 plus 15 plus 8 plus 8, and that's going to be 46 meters. Perimeter is found with addition. Okay, let's draw another rectangle. Let's do about like that. And this time, I want you to divide up the inside of the rectangle. Maybe this is a bathroom. Sorry, I didn't mean to do that. I'll tell you what, let me not do that. Don't erase yours. If you've already drawn it, that's okay. I'm going to build this one with squares because I want you to actually watch what I'm doing here. And those are not squares. Let's get a square unit. Still want to use that analogy of the bathroom. So let's say that I'm going to put tiles down in my bathroom. And if you have ever laid tiles, which I have not, but I know the process, you just have to lay those tiles side by side. Same concept with carpet. You're putting those square units side by side. Let me go one more. And then I did a row. And I'm sorry I'm being so picky, but it really needs to be straight for this to work. There we go. We'll stop right there. It's still not straight, is it? Okay. Let me back off here and take that one away. And let's just make a different shaped bathroom. So there's a row. Here's another row. another row of tiles. There's a perfect square, 3 by 3. But let's go one more. Let's do it this way. Okay, to get an area, this is maybe 3 yards wide and 4 yards tall. So the area is the amount of space inside. Area is coverage. So I can see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of these square tiles. Area is found by multiplying the length times the width. 4 times 3 is 12 square units. And in this case, I'm using yards. So perimeter is just linear units. Area is square units. And here's the definition of volume. Volume is the number of cubic units needed to fill a space to capacity. So things like swimming pools and refrigerators and soup cans have volume. How many cubic units would it take? Cubic units goes with volume. Square units, remember, go with area. Volume is the number of cubic units needed to fill a space to capacity. So let me bring back my shapes that I have now lost because I drew that area model. This is the one I'm interested in especially. So let's go with this first one that looks like a Rubik's Cube. I'm going to just copy, then again, this is item 33. So I'm just going to bring this one in for the moment. Let's study this shape for just a moment. Do you see those cubic units? They're little cubes stacked one on top of the other. When I used to teach geometry, we started our volume unit with sugar cubes. And I would give the students, say, 100 sugar cubes and see the different models they came up with. Some people built cubes, some people built weird shapes, but they all had an equal volume. So sugar cubes are a very good way to teach your children about volume. Legos are another good way if you can find perfect cubes. But let's study this shape for just a second. Let's look at its length. How long is this big cube? It's 4 units. Let me not put it in there. I thought that would be smart, but not so. It's 4 units long. It is 3 units wide. Nope, be careful. You have to actually count those. It's 4 units wide. It's not necessarily to scale, so be careful. Make sure you actually count those units. And then how tall is it? There's 1, 2, 3, 4. We may get some orange in that last one where the yellow and red cross. but it is 4 units tall. That's what makes this perfect cube. It's a 4 by 4 by 4. That is a perfect cube. So to get the volume of a perfect cube, you can count the cubes, or you can multiply the length times the width times the height. And that's the same as saying 4 to the third power. If you wanted to do it that way, you certainly could. But that would give you 64 cubes to fill that shape. 64 cubic units. Okay, let's take a look at this one, which is an unusual shape. I do not have a formula for this one. We could write a formula, I'm sure, but we won't need to do that. Again, this is item 33. And to do this one, I'm just going to count the cubes. Okay, so let's take it a piece at a time. Let's look at this element first. This is called a composed solid. You could even do it this way. This is probably a better way to do it. Let's focus on this top row. Okay, this top row is 4 units this way, 1 unit this way, and 1 unit this way. So that volume, bear with me a second, I need this space. What is the volume just of that part that I colored? Volume would be length times width times height, so that's going to be 4 times 1 times 1. So the volume of that piece that I colored is 4 cubic units. And you can see that that's true. I can tell you looking at that that's 4 cubic units. So coming down the line, let's look at this next step. Maybe these are gold blocks. So in this step, how many of those gold blocks would there be? Well, let me do it this way. This top one has 4 cubic units. The next step has 2 of those, so 2 times 4 is 8 cubic units. Okay, let's come on down to the next step, which has, you get the idea, there's 1, 2, plus 1 more, 3 cubic units by 4 this direction by 1 thick, or you could just say 3 times 4. There are 3 of those towers, so that's 12 cubic units. But be careful, because the pattern doesn't hold here. When you get to that bottom step, what happened? There's 1, 2, 3. And then they added 2 this time. So I would have expected that 4th one in there, but this step is a lot wider than the ones before it. So this one is going to be one of those towers, which is 4 units, but there are 5 of those in this one. So what if they wanted to know the whole volume here? There's 20. There's 12. Let me get my yellow one back. There's the 8. How would you get the total volume of this thing? Well, total anything is addition. So I would add up the steps. And I'm thinking 44. Let me double check myself. You guys know how I am with adding in my head. Yes, 44 cubic units for the total composed volume. So in this one, I didn't have a formula. I just had to do some reasoning just to count that one up. Okay, there is one more, and I need to find it. I'm sorry that I lost it. I had them all ready to go, and then I decided to draw that area model, and I lost it. So bear with me. I'm saying that a lot lately, aren't I? Okay, where did he go? Hopefully you have already cut yours out and are not having to hunt like I am. There he is. I apologize for that. I should be better organized. Okay. Let me see if I can paste it right in here. I am going to crop it down to make it a little bit cleaner. Okay, this one is like a cubic snowman. Got all those cubes stacked up. I think I can squeeze it in right there. So let's find the composed volume of this one. I should have started with this one. It's a little easier, I think, than the step one. So here's this 1 cube on top. So we know that we have 1 cubic unit in the yellow. Okay, this one, which I will make blue. Now I'm going to use a formula. I like formulas because that means I don't have to worry about the things I cannot see. Sometimes these composed figures are very, very tricky because you can't always see the things that are underneath or behind. So for this blue one, I have a length of 2, a width of 2, and a height of 2. So the formula is 2 times 2 times 2, which means the volume of this blue piece is 8 cubic units. So however you get the volume, just be sure that you count all of the cubes. And that's 8 cubic units. And then finally, this one at the bottom. Again, there are things that I cannot see behind there. I don't really like that. I like to be able to see all the pieces. Some people can visualize this very well in their heads. They can just picture what's back there. Other people cannot do that, and that doesn't mean anything. It's just the way we think. So I'm going to do the length, which is 3, the width, which is 3, and the height, which is 3, and use my formula. And then I don't have to worry about what I can't see. That's going to be 81, I believe. I will check that. That seems like an awful lot. That's not right. It's 27. I went to the 4th power. 3 times 3 times 3 is 27 cubic units. But you saw an example there of how I am programmed to always ask myself, does it fit? 81 cubic units, that doesn't fit. That's too much for that pink box. So to get the composed volume, I would say 1 plus 8 plus 27. And that is going to be, I believe, 36. I'm going to check that though. If you were here with me, we could just check each other's work. But since you can't talk to me, the composed volume is 36 cubic units. And that is a look at volume. How many cubic units does it take to fill the space to capacity? Very different than area, which is just a two-dimensional thing. And perimeter is really just a one-dimensional thing. It's just the distance around something. We will be looking at lots of examples of volume using formulas in most cases. So I just wanted to give you a chance to understand what volume is about, and then we'll look at how to actually calculate it using some pretty complicated formulas. So I will see you soon. I hope you have a great day. Bye-bye.